Hi, I'm Jordan Baton from Limit State, and today I'll be explaining how to use the Stabilize component in Peregrine, the structural optimization plugin for Grasshopper. The Stabilize component is a post-processing action that takes a solution or constructed topology and ensures that the structure is linearly stable under the specified loads. This step should generally be the last optimization in the workflow, as other components may introduce a state of unstable equilibrium. This is the half-wheel example file located in the free example files folder. It has been solved with a nodal density of 8 and post-processed using the geometry optimization component. If constructed, the displayed solution is likely unstable and susceptible to global instability. This is why the stabilize component should be used. The solution data from the previous post-processing action is connected to the stabilize component, which then feeds into the view solutions component. This produces the solution shown here. Ties are now provided to the supports, which will increase the stability of the solution and stop buckling happening at this critical location. The stabilize component has 5 inputs. Solution data. This accepts the solution data from a previous optimization process. In this example, it's connected from the geometry optimization component. The max joints input states the maximum number of joints in the solution that the component will accept. This is because the calculations involved in ensuring stability requires a high computational effort. The default threshold is set to 50, however users can manually change this. The load factor input is a user-specified target value, which is set as a default of 1. If the calculated load factor is less than this, corresponding buckling modes will be analysed to identify the most critical members. These members will be resized or additional elements and previously eliminated support points added to suppress the buckling modes. The termination gap input is a measure of the allowable percentage increase in the solution. When the stabilization routine gets to this value or finds an optimum stable solution below this, it will be allowed to terminate. The add supports input is a boolean, which allows the user to select if they want the stabilization component to consider areas of the geometry that were specified as supports, but were not active in the previous optimal solution. The supports may provide restraint for subsequently added stabilizing elements. Thanks for watching. For more information, visit our website.